Okay, we have a rates of change type question. Okay, liquid is poured into an inverted cone at a rate of 3 centimeters cubed per second. So centimeters cubed represents a volume. So then this must be dV dt because it is respect to time. So I know that dV dt is equal to 3. I'm then given information about the cone. The cone has a radius of 20 centimeters and a height of 48. Okay, so chances are I'm going to have to use those values. Find the rate. So this is what I'm now looking for. Find the rate at which the height of the liquid of the cone is increasing. So this is ultimately what I want. I want to find dH dt, the rate that the height increases. And I'm not talking about rate with respect to radius or rate with respect to anything. So when I'm assuming, what I'm assuming here is that rate is respect to time. So I go and I draw out what I'm looking for. So I have dH dt, okay, or that's, sorry, what I want to ultimately find. I've been given dV dt, okay, and so I need an expression that will allow me to find dH dt, so it will incorporate a h in here. Okay, so I need dH and it has to be on the top line. Okay, and I need to leave my dt in it. I don't want the dV, so that's what I want to remove. Okay, because it's not over here. Okay, I don't have a dV over here. I have my dH and my dt. So I'm going to remove it by going like this. So now I have my dVs will cancel out, and that will allow me to get dH dt. Okay, so I need to look at dH dV. Okay, or I can look at dV dH. Okay, so I can look at it either way around, and it's probably easiest to look at the volume of a cone, which is a third pi r squared h, and differentiate that with respect to h. Okay, so if I look at this cone here, so I want to find the rate, okay, at which this is increasing. Okay, now my radius here is not 20. My radius of the main cone is 20. So the maximum radius it can be is 20. And the maximum height it can be is 48. Okay, but for the height of the liquid, so if I'm just talking about the cone for the liquid, okay, so this is an expression just for the liquid, the cone, liquid cone, not the full container. I'm just looking at this section, okay, which is radius and height. But that is a similar triangle to the main cone, okay, which is a height of 48 and a radius of 20. Okay, so if I look at similar triangles here, I know that r over 20 has to be in the same ratio as h over 48. Okay, and sorry, to go back to this, the reason that I'm doing all of this is because this equation here has two variables. And I can't ever work with two variables, so I need to somehow write radius in terms of height. Okay, I don't want a radius in this because I'm looking for dV dH. So it doesn't have a radius in it at all. So my radius is equal to 20h over 48. Okay, so then I can take my volume, which is a third pi r squared, which is now 20h over 48 times h. Sorry, squared. Okay, so my volume is a third pi, that'll be 400 h cubed when I multiply in the h, and 48 squared will be 2304. Okay, so this is my expression for volume. Okay, and then I'm going to just multiply the bottom line, so 3 by 2304 to get a common denominator. So that now leaves me with pi times 400 h cubed over 6912. And you can simplify that if you want. 400 divided by 6912, okay, if you want, but there's no massive need to. Okay, then I've got to differentiate. Okay, calculator. So now I want dv dh, which is just differentiating the h. So the 3 comes in front. 400 times 3 be pi times 1200 h squared over 6912. Okay, so this is my value for dv dh. Okay, which is pi. I'm going to leave the pi like that for a minute. 1000 h squared over 6912. Okay. Now I actually want dh dt, dh dv. So to get dh dv, I'm simply inverting the fraction. Okay, so dv dh was this. dh dv, I'm just flipping it around. So 6912 divided by pi 1200 h squared. Okay, and I now have, going back to my expression here, I'll bring that down. I have dh dt is equal to dv dt, which I was given is 3, times dh dv, which is this one, 6912. I'm going to write this properly now. 1000 pi h squared. Okay. I was told this is equal to 3. So dh dt is equal to 3 times 6912. Okay, and there's a couple of things here. You can just simply multiply it in, or you can say that 3 goes into 1200 400 times. And I've got dh dt is equal to 6912 over 400 pi h squared. Okay, which is my expression for dh dt. I'm asked when the height of the liquid above the apex is 36. Okay, so now I'm told at h is equal to 36. I'm just going to change colour because I'm kind of keeping it all in the one page here. I've got 6912 over 400 pi times 36, and I can stick that all into the calculator. And I get 0.0 1528 centimeters per second. Okay, and that makes sense. The volume is only 3 centimeters cubed per second, so the volume is moving very, very slowly. Okay, hence the rate of the height would be moving very slowly as well. So find the ultimate question was find the rate at which the height of the liquid in the cone is increasing when the height of the liquid above the apex is 36. Okay, so, and that's what we did. We had height of this cone here. Okay.